In this example, we have question 7, which is non-calculator, and we've got to figure out what the expression for this integral is here, and we're going to be finding the antiderivative of the integrand. To me, this looks like something with x squared in the denominator, so we might be looking at maybe an inverse trigonometric function. If we look at our answer choices, we've got B, C, and D with that inverse, and A has a natural log. It could be the natural log, but if we think about this, if we find the derivative of the expression in A, we'll have to multiply by the derivative of the inner function, and I don't see that up here in the numerator. The derivative of negative x squared plus 6x minus 10 is negative 2x plus 6. I don't see that up there. So we know then that part A is not correct. If you wanted to, you could figure out for B, C, and D, you could just take the derivative of each one of those and see if you wind up with the integrand. However, what I'm going to do now is I'm going to take you through a process where if you didn't know how to do that, or maybe this was a free response, then you could actually figure this out using just this piece right here. When we work with a problem like this, we're going to be completing the square. And to do that, I like to have a coefficient of just 1. So I'm going to factor that negative sign out. In the denominator, I'll have x squared then minus 6x plus 10. I'll also be able to factor or get that negative sign out of the integral symbol, or negative 1. So I'll have the integral then of 1 over x squared minus 6x plus 10. And I'm leaving a space here on purpose. So watch what happens here when I try to complete the square. Half of negative 6 is negative 3. Squared is 9. Now, in the denominator, I can't just go adding 9. I've got to offset that by also subtracting 9. When I do that, I'm going to wind up with 1 over x minus 3 squared. And then I'll also have a plus 1. Now, this is really, really good for us. It's really good because if I want to find the antiderivative of this, I basically have 1 over something squared, that's x minus 3 plus 1. The antiderivative of that, or the function that has a derivative of 1 over something squared plus 1, is the inverse tangent. And I want to keep that x minus 3 right here on the inside. I also want to double check to make sure that I don't need to do anything special with the x minus 3. So if I were to take the derivative of this answer right here, I would have to multiply by the derivative of x minus 3 using the chain rule. But the derivative of x minus 3 is just 1, so we're good to go. If you're having trouble going from this step to this step, I'm going to give you a hint. You could use u being equal to x minus 3. Then you'll notice that du dx is equal to 1 and du is equal to dx. So you would have the opposite of the inverse tangent of u plus c. That would be your antiderivative. And then you just have to substitute back in for u with your x minus 3, which is what you had up here. Whichever way you work this problem, you're going to wind up with B here as your correct answer. C is incorrect because of the plus sign right here. And then there's no negative sign out front for part D, so that one's not correct either.